Okay, looks like we are live. I'm here today with a couple of folks to talk about Lagrange, and it's a little different in the past than when we've done some of these spotlights because now we have the ultimate guest co-host, Brandon Curtis, who is very technical, and I think we're going to be diving into some really cool conversations here with Brandon. So to kind of kick off this whole discussion, how about maybe Ismail, do you want to give a quick introduction to yourself and to Lagrange? And then I'll let Brandon give an intro, and then we can just take it from there.
Yes, of course. So my name's Ismail. I'm one of the co-founders of Lagrange Labs. So we are a company that focuses on ZK, zero-knowledge proofs. And foundationally, we focus on the application of zero-knowledge proofs across a wide variety of verticals within crypto. The two core products that we build are ZK Prover Network, which allows us to do general-purpose, high-performance decentralized proving on EigenLayer for a series of our roll-up partners, and a ZK coprocessor, an application that sits on top of our prover network that allows us to do highly specific types of compute with very simple developer ergonomics for many of our DeFi and NFT customers.
Fantastic. And I'm Brandon Curtis, and I'm the Director of Research at EigenLabs.
Awesome. Okay, cool. So I'm going to actually leave the conversation to Brandon, and I'm going to step away. So look forward to listening in on this conversation, and I'll let you guys take it from here.
Thanks, Nader.
Wonderful. Thank you so much.
Yeah, so these spotlights are a great opportunity for us to talk to some of the folks who are building really exciting services on EigenLayer that are going to push what is possible for developers and for users by leveraging services that can be provisioned on EigenLayer as an AVS. So maybe just to start things off, for those that are totally unfamiliar, can you give us just a high-level overview of the Lagrange Prover Network? What sort of service are you provisioning? What kind of customers do you have? And what makes Lagrange unique?
Yeah, so a Prover Network is a way to generate proofs in a decentralized fashion with high guarantees of reliability, low cost, and liveness. What this lets us do is to take zero knowledge, a fundamental component of scaling chains and applications, and do so and apply it in a way that is decentralized and allows us to serve proofs with guarantees that the applications relying on them will remain decentralized. And so we work with many of the top roll-up teams in the space. We had a very large announcement with ZK Sync very recently, as well as a lot of RAS platforms, teams like Caldera and AltLayer servicing stacks, including ZK Stack, CDK, Scroll Stack, and more. And very broadly, what a prover network does is it has a series of nodes who run provers. The same way you have an L1 with a series of validators, a prover network has a series of provers. It has a mechanism wherein work is assigned to a prover within that network who generates that proof and returns it. They receive a reward for returning it correctly and a penalty, either in slashing or non-payment, if they behave maliciously. Think of it like the next iteration of an L1. Instead of validating blocks, it generates proofs.
So if I'm building a ZK network or application today, how am I probably going about this now?
Yeah, the way you do it now is centralized, right? You take your prover and you put it in AWS, or you put it in G-Cloud, or you put it on a bunch of Hetzner machines. And you have that centralized prover deliver all of the proof that's used for all of your customers. So the current form, the Elastic chain, for instance, is proven on G-Cloud. Linea is proven on, I believe it's AWS. And so while this is great and you can build highly reliable systems in a centralized context, it doesn't get at the ethos of why we're building this, right? If Google Cloud can shut off the entirety of the ZK rollup ecosystem, if Azure can shut off the entirety of the ZK rollup ecosystem, the amount of decentralization that our chains and our rollups get becomes limited. What a prover network does is take the concepts of efficient markets and apply that to being able to build decentralized proving to span this entire customer base.
So in addition to these like liveness benefits that a network that adopts a decentralized proving network through Lagrange, what other benefits might they receive by moving from in-house proving to a decentralized network like this?
Yeah, so one of the core ones is ergonomics, right? It's much easier to deploy on an existing infrastructure designed for high scalability and high throughput proving than it is to spin one up in-house. Load balancing, multi-region resilience, all of this stuff, the concurrency on proving, burst tolerance, all of this stuff has to be built in-house right now, which is great if you are, you've raised hundreds of millions of dollars like one of the early ZK teams. Not great if you want to build something on top of a ZK VM and you don't have $100 million to hire world-class engineers. And so you can take all of that resilience, you can have one entity specialized in building that in a decentralized context that can then be leveraged by everyone. If we think about the foundation of crypto to begin with, right, the reason that we need a high throughput and resilient L1 for transactions is to facilitate peer-to-peer payments, right? You have SWIFT if you want to do an enterprise payment, but you have a blockchain if you want to have a permissionless payment. By extension, prover networks and prover markets are that same logic. If you want to do proving and you want that to be done in a way that is commodity that everyone can leverage and everyone can use their applications, a decentralized network is the only way to do that.
So Lagrange is being built as an AVS on EigenLayer. Can you talk a little bit about what is an AVS? Why build as an AVS? What kind of functionality does this provide that helps you meet these goals for Lagrange Proven Network as a service?
Mm-hmm. So I hope everybody who's watching this understands the extent to which I am a bull on EigenLayer. We've been building in the EigenLayer ecosystem for probably 2 years at this point. And it's an ecosystem that we believe very strongly in. And so what EigenLayer offers is a few things. Firstly, any AVS deploying on EigenLayer gets a highly decentralized set of operators out of the bat. People who are familiar with being AVSs, running AVSs, and participating in these networks. Which means that world-class operators, Coinbase, Kraken, OKX, P2P, Nethermind, are kind of at your fingertips. And Lagrange has worked with many of these teams for also the better part of a year and a half, 2 years at this point, and are very fortunate to have them as participants in all of our proving infrastructure. On top of that, what EigenLayer offers is a very low cost of capital, which is a fundamentally amazing bootstrapping mechanism for launching networks that have high operating cost, right? A proving network generating proofs is a lot more expensive than validating blocks on a blockchain. And so the payment that you have to receive if you're an operator who is running a prover and has a stake is going to be weighted very heavily towards the cost that you have to expend by running a prover. So the low cost of capital that you get with restaked ETH is the best mechanism available in crypto to bootstrap these types of decentralized high operating cost networks. It's the same logic as DeepIn and decentralized AI, but it's applicable to ZK.
You've described the Lagrange Prover Network as a network of prover networks. So what does that mean? Why build it that way? How does that improve some of the properties of the service that you're looking to provide?
Yeah, so we talk about this idea, this internet of proving. The fact that proving requirements are not, heterogeneous or not homogeneous. They're fundamentally heterogeneous. There's a series of requirements that every single one of our partners has, all the way from token staking to economic designs to auction mechanism configuration to permissioning requirements if they're operating in the geography that requires AML laws, KYC laws on their operators. And so what you need is a very flexible market that can be quickly instantiated to allow you to run decentralized proving with an incentive compatible mechanism in an order book style that allows your network to leverage kind of all of the infrastructure that exists from Lagrange. And that's what we do. So we have a specific portion of that network that's doing proving for ZK stack chains and ZK sync. We have a specific portion of our network that we call subnetworks that does proving for our ZK coprocessor. We have a specific portion of that network that does proving for a lot of our cross-chain clients, people like Layer 0, people like Axler, people like Polymer, that is specifically designed for proving for cross-chain use cases. And by allowing ourselves to easily instantiate these subnetworks, we don't face the constraints of having this monolithic kind of input gateway where everyone's trying to shove all demand through a single funnel that scales latency proportionate to overall size rather than the proportionate to what your application requires.
I think a lot of people will be, pretty familiar with how you might launch a chain and have a whole bunch of validators that kind of trade off which blocks they're organizing transactions in and then publishing those. But they might be a little less familiar with what the life cycle looks like for ZK proving.
Yeah.
Can you kind of walk us through a day in the life of a ZK proof
Yes.
from actually the request coming in from the network all the way to the end result?
I love that. There's this movie. I can't remember the name. It's about this arms dealer in Africa. It starts with this like life cycle of a bullet, where it goes all the way to the manufacturing of the bullet, all the way to its usage. And I always think it's a very kind of very funny story to start all the way from like soup to nuts on a lot of industries. So when we think about a proof very broadly, it really starts with the request that an application makes for needing to generate some proof for some productive purpose. For a roll-up client, that is, a batch of transactions being written to Ethereum for a ZK stack chain. Think abstract, Sophon, Treasure, etc. For a ZK coprocessor, it is, hey, a user on chain requests a proof of some computation over the state of that blockchain. But in all of those situations, there's an input request. There's something that has to be proven. There's a circuit that has to be run, and there's a public input that's going to be used. And so the network receives that request, and it uses that request as part of a double auction. The way our network works is a bespoke double auction mechanism we call DARA, which is double auctions for resource allocation, which effectively allows a requester to express a price preference over the proof computation and bidders to express price preferences over the generation of those proofs. There's a composition rule that matches the request to generate a proof with bidders who want to generate that proof, such that the final composition maximizes utility, such that we can generate as many proofs as possible by matching bidders and requesters. Now, once that is that matching happens, that proof is assigned to a prover in our network, and that prover has preloaded the relevant circuits and generates that proof and returns that back to the requester or back to the gateway that ran the auction. And from there, that proof is returned back to the requester. And the way that effectively works is you're able to kind of streamline how a proof is sent into the network and how a proof is returned out of the network, such that there is an incentive-compatible mechanism to derive the assignment of that proof to a prover who is then incentivized to meet the requirements in generating it. But from a user standpoint, all you have to do is send the request and wait for your response.
So earlier you talked a little bit about some of the design goals for the network. So, reliability, liveness, censorship resistance. What do these things mean in the context of ZK proving? And how are you accomplishing this by building Lagranges in AVS?
Yeah. So what this means is that when you want a proof, you get your proof. So if you are a ZK rollup, your chain can't progress if you don't receive your proof. If you're a DeFi app and you're predicating some function or some callback on a coprocessor, your app can't progress if it doesn't receive its proof. If you're an Ethereum validator and we're post-beam chain, you need to generate a proof of block execution. Well, Ethereum doesn't progress if you don't generate that proof. You get a penalty in that case. You get slashed as a validator. So a bunch of places in crypto, the delivery of a proof back on a user's request on time is an imperative for the function of these centralized applications. And so by extension, if you are sitting on a piece of infrastructure that's mission critical for you to remain decentralized, that piece of infrastructure by extension must be decentralized with a high guarantee of liveness. And what EigenLayer offers is a great mechanism for us to build this type of network, leveraging an existing set of validators and leveraging an efficient payment, slashing, and staking workflow. And so that's kind of how Lagrange functions to that end. And now, how do we actually guarantee liveness? Well, this has to do with the concept of staking and slashing for proof generation. You bid in an auction to generate a proof. You receive, let's say, the task that you have bid on because you've bid the most compelling amount with respect to the auction. And then you generate that proof and you get paid. Very simple, happy path. Let's say you're a malicious actor and you're like, I want to shut off ZK sync. And so you refuse to generate that proof. Well, you now get penalized. You get slashed such that the principle that you held as a bond for your correct behavior gets used to ensure that you behave in line with protocol function.
So I think some people have argued that ZK is one of the very coolest things to come out of this industry, just end to end.
Yeah.
And rollups are pretty well established as the way forward to solve a lot of the scalability challenges that blockchains have and actually enable applications to be built in a scalable way. How does Lagrange kind of enable this world where we have maybe hundreds or thousands of different applications that are deployed on rollups that want to make use of ZK?
Yeah. So I think one of the things that you touched on that people overlook in crypto is the extent to which crypto as an industry is the world leader in zero knowledge. There's no ambiguity that the AI industry outside of crypto is more mature in its embodiments of AI than the AI industry in crypto, right? DeepSeek is not a crypto company, but we will use DeepSeek within crypto. Distributed computing and high throughput computing outside of crypto for HFT and for say big data applications within FANG companies is going to be more complex than we generally see in crypto. There is no other place in the entire world where the industry is as mature with ZK as it is in crypto. Crypto has been the financing mechanism for ZK R&D. Crypto VCs have almost entirely paid the price of $1 billion in private capital for an explosion in R&D. And if you look at how ZK tech is being used outside of crypto, and TikTok did something with it this week, they're using tools from 2019 that a ZK developer in crypto would never even consider using. So we are, as an industry, on the forefront, not just of the application of ZK to crypto, but of ZK overall. And that's an incredibly exciting positioning to be in. And so in line with that, this is, I think, one of the flagship technologies that crypto can kind of plant the flag and say it's developed. It is in many ways the future of scaling a lot of aspects of crypto, all the way from Ethereum consensus to, as you put it, rollups, and then the applications sitting on those rollups. And what that means is you need to have a sensible way to do massive proving at an internet scale for decentralized applications. And I don't believe that the final form of having thousands of ZK rollups and thousands of apps using ZK is everyone independently deploying a bespoke infrastructure in Google Cloud. That is likely not how it's going to be. What you're going to need is a universal layer, and in our case, a layer of layers that allow you to easily instantiate and deploy a decentralized prover market for your application that has the requirement set that you need, that will be able to deliver a proof exactly when you need it,
So, one of the great things about a blockchain is that if you want to go and take some business logic and put it on chain and create new functionality that anywhere in the world can access and they can compose it all together, you don't have to go and set that network up. You can just make use of these existing networks. You can go and deploy those contracts and you're good to go. So, you mentioned applications a couple times, and I think most people are probably familiar with ZK rollups as an obvious consumer of ZK in general and requiring proving. What other sorts of applications might leverage ZK techniques to meet their goals and deliver services? Yeah. And how might the impact of new services becoming available that let you plug into ZK in much the same way that you can plug into a blockchain and launch smart contracts? How does that change really the design space for developers that are interested in using this technology?
Yeah, so I'm going to go down the stack kind of and how I see ZK being relevant to your question, right? You have the foundational layer, which is ZK rollups and maybe consensus proofs or proofs that are being used as part of consensus on Ethereum. And then we move up the stack and we talk about the blockchain related applications that'll use ZK, right? We can say, okay, well, what's one level above L1s and rollups? Interop protocols. It's very likely that as we move towards L1s that use ZK as part of consensus, you're going to end up having interop protocols that are using state proofs instead of economic guarantees for bridging. We're already seeing work that Layer 0 and Axler and similar teams are doing there because they directionally understand the way things are moving. We move a level up and we say, okay, there's certain things you can write in the execution client of Ethereum or a rollup, right? You can write a state transition in Solidity in most of these cases, or in Move, or in some other VM language. But there's a lot of things you can't do. You can't run a large-scale data-heavy computation over blockchain state. You can't run a bespoke, ML model to derive a new resource or asset allocation on chain in a pool. And so this stuff is currently being done either off-chain centralized, or maybe with some crypto economic guarantees. But directionally, we can see that these applications will move ZK. Maybe 1 year, 2 year, 3 year, 5 year. We can argue about the timelines, but directionally, they will become ZK as the technology becomes more performant. And so this means you'll have things that are more expressive. You can have ad targeting done on chain. You can have resource and reward targeting done on chain. You can have agents that are used to allocate your assets and change your chain interactions that are verifiable with respect to what they do with respect to your request, such that you sign your request and the agent, you can verify it's done the thing correctly and it hasn't maliciously moved your assets for some purpose or gone rogue. And then we can go a level above. And these are some applications that I think we've seen nobody talk about yet, but that I think we'll see a ton of. And this is how ZK networks and ZK technology will apply proofs outside of crypto. There's work done with UAVs and trying to ensure that you can have these drone networks for surveillance and defense purposes that can communicate location to each other without disclosing exactly where they are. There's work done with like radiography for nuclear weapons, wherein you're trying to proving that effectively there's been some disarmament of a nuclear weapon without revealing the properties of the weapon. And so you have these applications that are significant to national security and national defense that will use ZK. And as the industry that's definitively at the forefront of this, I think it's highly likely that the technology that we build will be purposed to that. And hopefully the proofs being generated will be done on Lagrange.
Yeah, I think from some perspectives, when you're building in crypto and you're trying to make use of technologies like ZK, we're already starting on hard mode, because you're already talking about trying to involve a decentralized group of participants instead of just permissioning specific roles and having specific actors go and take care of those sorts of things. So we're kind of used to the fact that when you put data in and get data out of these systems, you get a bunch of guarantees. And you don't even have to think about it. You don't have to do anything. That's just the service that's being delivered.
Exactly.
When you just call, an API for some Web 2 application, and it returns some data for you or does some calculation, there's a question you can ask of, what kind of guarantees do you have that is correct? And so I think I totally agree that as this technology becomes a lot more accessible, and as the barrier to entry comes down and you don't need to go and spin up, your own clusters to actually being able to provision the proving for your own application, you could basically apply this anywhere. And a lot of it just comes down to accessibility and cost and those sorts of things.
Exactly.
Yeah, totally. So if... So what are some ways that you're actually seeing developers, networks, protocols actually make use of the Lagrange Prover Network?
Yeah.
And ZK in general?
So we'll go from boring to exciting. So starting, I don't want to say boring, but starting as the very obvious one, rollups. There's a bunch of rollups that are ZK rollups. ZK Stack is a big announcement we did recently. Done some announcements with Caldera and AltLayer as well that we'll have some more stuff coming out on very soon. But kind of right down Main Street. Then there's stuff with our coprocessor, which I think are more non-obvious. The building of rewards programs with teams like 1inch, EtherFi, Frax that use ZK that can derive proofs from on-chain state and then leverage those proofs as part of issuing rewards or some type of protocol function that requires more data than the execution environment can access right now. I think that's very exciting. And then there's stuff that are really non-obvious, like NFTs. We did some great announcements with Azuki, and we'll do some stuff with Sappy Seals, another project that I'm very excited about, over using ZK for reward programs and reward issuance for NFT collections and NFT holders. This is how do we take proofs and we jam these into the application level such that protocols can start building really, really cool stuff for their users. And then we can go to some stuff that we have yet to announce yet, that I think will be very cool, which are things related to ZK in the context of machine learning, and then in the context of aerospace and defense. And then expect more coming very soon from Lagrange pertaining to zero knowledge in those two areas.
Very cool. Yeah, anything else you want to mention about the work that Lagrange is doing?
Yeah, so I'd like to say that, I think we're at this very interesting inflection point in crypto. We are seeing the market get very, very hot, and the market's getting very, very hot, often around designs of infrastructure that are less than sensical. And that's fine because we're seeing, massive consumer interest. And that means that people often say, well, why are we building all this infrastructure, all this ZK tech, if it's not relevant? But they don't ask about directionality and the speed to which we're moving towards an endpoint where the stuff is actually practically relevant and it's much more secure. And so from where I'm sitting, obviously I have a vested interest in ZK being successful. It's been getting faster and cheaper by about 1 to 2 orders of magnitude per year over the last, say, 3 years. And when I look at where we are now, I can see about a 2+ order of magnitude improvement based on stuff I'm seeing coming out of the pipeline. That'll be, 12 months, 18 months, 24 months to unlock that. And so we compare economic and optimistic solutions to ZK right now, and they're about 1 to 2 orders of magnitude cheaper. And now all of a sudden, like, okay, well, we're probably 12 to 24 months away from the stuff actually being comparable in cost. And then we're probably maybe 24 to 36 months away from this stuff actually being cheaper than the cost of capital of a lot of economic systems. Hence the beam chain and replicated execution being replaced by proof verification. And so, we're at this precipice, as I was saying, wherein we can see that this final state that we might think is 10 years away, or some people might think is 10 years away, really is only a couple of years. And in that period, I think we'll see kind of this hegemony of ZK. More and more applications will be consumed by ZK. Something that was economic, something that was optimistic, something that was off-chain will slowly start being replaced until we get to the end where there'll be no more ZK apps. There'll just be apps, and every app will use ZK.
If I'm a developer and I'm interested in learning more about Lagrange's doing, and maybe I've taken a look at my own applications and thought that there might be just some ZK solutions in there, but might be hard to set up. Now that like Lagrange Proven Network is coming online, where can I go to learn more and try to understand some of the capabilities?
Yeah, so Lagrange's Proven Network and our ZK coprocessor are both online right now. The Proven Network's in production. The ZK coprocessor on testnet. It should be in production soon. And so no matter how familiar you are with ZK, if you want to deploy your own application on the Proven Network that runs as an auction, you want to deploy your own circuits, or if you just want to write a SQL query and compute over some data and get a proof, we support all of that. And so we're very, very excited about kind of being able to offer this wide breadth of zero-knowledge solutions to our partner and customer base. And so what I'd suggest is go to our docs, go to our website, go to our Twitter, contact me directly, go to our Discord. We have sections in there for developers, and suggest some ideas, things you want to build. And our team was receptive, and we're always on hand to help assist.
Great. Yeah, I know that even within EigenLabs, we have some ideas about how we can take some of the products and services and things that we need kind of on the back end of the protocol and add ZK elements to them to reduce the cost or improve the trust model. Because if you can solve for actually requesting and getting these proofs, it's cheap to verify them on chain, and then you can tell users that you don't have to trust us at all. And even if you don't know or trust us, that you just have to trust the math. And so exactly. I think that as this design space really opens up and as the accessibility really increases, I think everyone's going to be reaching for these ZK tools.
I totally agree. I think ZK tools are becoming more accessible than ever before. And I think developers are starting to realize that. And credit to EigenLabs, you guys have really been on the forefront, both in terms of building infrastructure that is applicable to building ZK systems and in using ZK systems as part of your infrastructure. So credit to you guys, and has always been a pleasure working closely.
Yeah. Any advice for folks out there who are building services and might be considering building an AVS?
Yeah, I'd say, I remember people said for a while, oh, building an AVS is hard. And this was like 6 to 8 months ago. And I was like, it really isn't. Compared to everything else in crypto, building a chain, building provers, building all this stuff. AVSs at that point, to me, were one of the like not very hard things to build in this space, and it's gotten even easier. I really think that the burden to actually launching and building an AVS on testnet production is lower than it's ever been, and there's more opportunity to leverage restake security in this market than there has been before. So I would really suggest to anyone who wants to build an AVS, dive in. Like, you can spin up an AVS that's testnet grade in like a week, probably. And you can test out your market in 2 weeks. Like, you can really get something that's non-trivial up and going very, very quick. And if you work with a team like, you know, EigenLayer or Opacity with some other, not Opacity, sorry, EigenLayer, or, you know, the shit I'm talking about.
Authentic, I think.
Authentic, yes. EigenLayer, Authentic. You can spin it up even faster.
Yeah, I love to hear it. That's our goal, is that when networks and protocols and applications are thinking about adding new functionality and kind of staring down the cost and complexity of just starting from scratch and building everything yourself, and then deploying it all and all the underlying infrastructure, and then going out and finding operators that have the capabilities that you need. Instead, you'll want to come to us, because it'll just be the easiest place to do a lot of that without needing to start totally from scratch.
It has been, and I think it'll continue to be.
Great. Anything else you want to add?
No, I mean, I think the only other thing I'd add is I think we'll see in the next few months that ZK's application outside of the non-obvious areas, or outside of the obvious areas, will become, you know, more visible than ever before. There are a lot of things that ZK, I think, will be very impactful for across ML, across AI, across agents, across aerospace and defense, that, you know, I think people don't yet realize, and it'll kind of blow their mind when they see it.
Looking forward to it. Yeah, I really appreciate you taking the time. We have Lagrange is just one of these great teams that's building a lot of really exciting stuff on EigenLayer. And we're just really looking forward to making it easier and better to build here and to deliver these sorts of services, because this is how we make all sorts of services much cheaper and much easier, and really expand the design space for anybody building inside crypto or outside even.
Thank you so much, Brandon. I have loved working with the EigenLayer team to this point, and we continue to be very excited for all the great things you guys are building and all the great features that we're going to leverage building on top of EigenLayer.
Appreciate it. All right. I think that brings us to the end here. If you have any questions about anything we talked about, definitely reach out. We're all over the internet, and happy to answer any questions that come up.
Perfect. Oh, last point I want to mention: we're organizing Proofpoint, one of our second actually event in Denver. I know EigenLayer, you guys are going to be there, and so anyone listening who will be in Denver, please come by Proofpoint. We'd love to meet you in person.
Denver's going to be great. Looking forward to it.
Wonderful. Thanks so much, Brandon.
Thank you. Have a good one.